Differentiation, part 4, coordinates of the turning point. Okay, the turning point here we see is the point -1, 2 and the point 1, -2. We refer to this point as local maximum and local minimum. It's just local maximum because, for example, this point here has greater y value than this one, and this one is a local minimum because, for example, this point here has smaller y value than this one. The local maximum and minimum they refer as turning point. We need to think now what this has to do with the chapter differentiation. So what is the gradient of the turning points? As we mentioned in earlier videos, the gradient varies from point to point on a curve. And we see that the gradient on this line is positive. And as we move closer to the local maximum, the gradient gets less positive until it has to pass from the point 0, so that it starts going negative because the line here is downhill. Similarly, close to the local minimum, the gradient here is negative, but it gets closer and closer to 0. At the local minimum, the turning point is 0, where it starts going positive again. So the turning point means that the gradient is equal to 0. For example, given an equation with y is equal to 3x squared plus 6x plus 1, and we need to find the coordinates of the turning point. Turning point is the keyword that dy and dx is equal to 0, so we differentiate this curve and set it equal to 0. And we solve for x, we find that the value of x equal to -1. But coordinates means that we need to find the value of x and y. So since we know the value of x, we substitute in this equation and we can find the value of y. So y is equal to -2 and the coordinates are -1, -2. More difficult question is to find the coordinates of the turning point of this equation. Turning point means that the gradient is equal to 0, so we need to differentiate this equation. But first of all, we need to rewrite it because there is a square root of x in the equation. We know that square root of x can be written as 2x to the power of 1/2. Now we differentiate this and we set it equal to 0. In order to solve for x, to find the value of x, we need to leave x on its own. Therefore, we add 4 on both sides and we get this. Now we need to think, how is it possible to find the value of x? Remember, x to the power of -1/2 is the same as 1 over x to the power of 1/2. So this is a very important step to be able to move back and forth with the powers. So it's 1 over x to the power of 1/2 is equal to 4. Multiply both sides by x to the power of 1/2, divide by 4. And now x to the power of 1/2 just means square root of x is equal to 1 over 4. Therefore, square both sides by 2. We get that x is equal to 1 over 16. But still, we need to find the coordinates. So if we know that x is equal to 1 over 16, we're going to substitute this into the original equation. And we can find that the value of y is equal to 5 over 4. Therefore, the answer is 1 over 16 and 5 over 4.